Uh,
Good morning, Sangli.
Good morning. Kankali, just take 5 minutes, sir, 5 times deep breath. Okay, Veramani?
Yes, yes, sir.
Screen send பண்றேன் தெரியுதான்னு பாருங்க சொல்லுங்க.
Okay, okay, sir. Okay, sir.
Kankali, can you see the big size screen?
Yes, sir. Yes.
Okay. Yesterday we have seen this in the last yesterday. This is basic. You have read it, na, this one?
Yes.
Okay, I will send the recorded video. You didn't receive, na, this recorded video?
Sir, I didn't get, sir.
Okay, okay. Next, industrial end user. You know, as industrial, what is industrial means? This distribution transformers available, HT transformer, then switch gear, and motors and fan and everything available, capacitor bank, everything available is industrial. Okay, what are the losses? They also say calculate the losses. They simply, it's a transformer, some losses available, 1%. Here, power come to EB power come to transformer. These losses also including transformer losses and panel port, everything, feeder and some losses, distance loss, cable they are putting cable and everything. So these losses include distance losses and capacitor bank, and then it's going to this panel. Panel there is no neglected losses. There is no big losses, and then going to motor. This motor have losses, and this is coupling devices also have losses. Same compressor and everything have losses. Compressor have more losses, and same this is a fan and blower pump, everything. Same we have calculated now from generators to the end customer. Same like this. This is also we have to do the calculations. Here they mentioned is a total losses is a typical network. See, in this transformer 95%, motor efficiency 90%, and another losses. This total mechanic system everything losses of 30%, efficiency 70%, and the driving coupling and they will and then it's going to pump flow control valve also available. There are also some losses available. The multiple total is a total efficiency is industrial is 50%. If you are giving this 2 unit, they are using only 1 unit.
Yes.
You understand now? This efficiency equal to output by input. Output by input. So output input is two unit. Output is 1 unit. So it is currently 50%. This is a very important one mark. This is you have to remember. If the industrial in distribution side, how much unit we have to generate for 1 unit using, then you have to tell 2 unit generated. 2 unit generating 2 unit, then you can one unit using for industrial. Can you understand this one?
Yes, yes, sir.
This is very important, very important 1 mark. Next we are going to see the billing. Billing already you know what are the billing available. HT tension line is a maximum other demand and actual energy kVA and kilowatt hour. Here you can see now.
Yes, sir.
Yes, actual energy and this one capacity maximum demand. This is for these two things they are using for the HT train. Then next, what are the remaining factor they are using means you already know this is capacitive demand means kVA apparent power and reactive power also. Sometimes their reactive power also they are recording. The meter always recording kVA, kilowatt hour, and kVR, everything they are measuring. And is one more, this is a very important 1 mark. HT line, what are the tariff system they are using? Then you have to write it kVA, maximum demand, and kilowatt, actual energy generated. And tariff structure, what are the tariff? Just to, what are the, they are using these maximum demand charges, energy charges, maximum demand kVA, kilowatt hour, and power factor penalty, and bonus or a bonus rate, and the fuel cost adjustment, electrical duty charges, and meter rental, lighting and power consumption. Time of the day means you change the peak hour to non-peak hour load change, and the penalty for exceeding contract demand, such meter LT side. This is 5 mark. Only you have to write the headline. What are the tariff system they are using means you have to write maximum demand, energy charges, power factor penalty, fuel cost system like this. No need to explain it. This is a maximum demand calculations. Only 30 minutes cycle. You can see this 2500 kVA for 4 minutes, 3600 kVA 12 minutes, 4100 kVA for 6 minutes, 3800 kVA for 8 minutes. Then you know now the 2500 into 4 minute multiplication is 3600, 4600. This is coming 1 mark. Every time is asking the 1 mark divided by 30 minutes. Total calculation 4, 12, 6, 8. Then maximum demand is 3. Average maximum demand is 3606 kVA. So only the calculation is 30 minutes. They always using this one, this calculation for the maximum demand calculation. Suppose this maximum demand sometime increase 3700 increase, they using for the calculation for they give the price for this 3700 higher value.
Oh,
The month maximum demand will be the highest among such demand value recorded over the month. The meter registered only if the value exceed the previous maximum demand value. This maximum demand meter is only the measure maximum demand. When it's increased above the maximum demand, it will register. Then the industry they will pay for this maximum demand highest value. If average maximum is low, industry facility has to pay for the maximum research for the highest value during this month. And this meter what are the special quality available? This meter have this logging recording relevant high accuracy, and this is a electromechanical trivector meter. To this electronic meter, this meter is converted to the electronic meter. Now we are using the all electronic meters, high accuracy and amenability to easily calculated to the day tariff, tamper deductions, measurement of harmonics, very important. This meter sometimes they asking 1 mark. What are the harmonics measuring? Total harmonic distortions and harmonics also measuring. Long service like long service is available. Amenability of remote data, SCADA boxes also they are using. Sometimes they are asking 2 mark. This meter, what is the purpose means is measuring for the recording for the maximum demand. It will suppose you have a particular time it increase the value, that time is register the value, then they will easily calculate the and put the money for this one for tariff system. And electrical load management, what is the electrical load management and maximum demand? Can you know, Ganguly, this one, electrical load management?
Yes, sir. Means how much load is used by the, what can I say? Mm,
Yes, this is electrical load management
the
means they manage
different
the
depart.
load. Suppose daytime higher load they are using, night time they don't have not use. Then they shift the load to night time. The Then means they will reduce the maximum demand because they are putting the maximum demand highest value. Then they put it the penalty. You understand now? Maximum demand they need to reduce. They because they will pay the money for the kilowatt hour also plus extra maximum demand. They need to reduce that maximum demand charges. Then they will distribute all the load to even. Suppose morning section all load running, that time it's a peak load, that time is a maximum increase. Then contract demand is, suppose they are getting the contract demand is 5000 kVA and billing level is 70%. Suppose the 3750 kVA is billing. Peak load condition, this maximum demand increase 4000, then they will pay for the 250 kVA extra amount monthly. 600 700 for 1 kVA means it will come 10 lakhs 11 lakhs coming, 20 lakhs coming. So they need to reduce that maximum demand charges. So the load management very very important. Understand na?
Yeah, yes, sir.
Yes, they need to remove the penalties and what are the unnecessary everything they need to reduce. This is totally going to the end user utility system. This is the load curve generation. Load curve generation, you know, is a day curve, 24 hours day curve. Is what are the load going on like this. They measuring the kVA is available. 7 hour, 8 hour, how much maximum demand they will calculating load curve using. Next is going to rescheduling load. The rescheduling basically வந்துட்டு this is a the shift the load. Electrical load, large electric load equipment operation different shift they plan to do the maximum demand, they shift to the another time. It's a, they need to calculate the timing which time the load required. According to that they reduce the maximum demand, then they'll shift the another load to another day means another hour or another shift they will change the load. This is a rescheduling load. And the storage of product or process material process utilities like revision. This is means, suppose they are using ice bank system. Ice bank system we can use for night time also. No, they don't know use the peak hours. So they shift the ice bank system everything is to the night hours for icing, for ice bank system for milk and dairy ice and lean period use the, what is the main purpose, they need to reduce the maximum demand, that charges need to remove. Next one, scheduling of non-essential. Non-essential same like this, peak hour load to non-peak hour. This is a one system is available. This automatic control all the load. Which load need? It is a programmable system. This is already the program. Which load they need to connect, another which load need to don't need. Then according to that, this is system working. This switch off, switch on the load. This accurate prediction demand, traffic display, and available load demand, visual and audible alarm, automatic load scheduling. This is a automatic load scheduling, automatic resources and recording metering, everything. This is scheduling of non-essential load. And operation captive generation, this is it. Every plant industry have the DG set. What is the main purpose for this? Suppose they will need to run, they need to run some load they need, but maximum demand increase. That time they use the DG generator for reducing the maximum demand. They don't need to pay the penalty. The main purpose is DG generator, they reduce the maximum demand. You know that every industry have the standby generator, have two generator have.
Yes, sir.
Suppose power cut also they are using, another one purpose is they will run all the load, that time maximum demand increase, they need to pay the amount. Better they will earn the DG, that load matching, the purpose for this using. Next one is reactive power conversion. This is a capacitor bank. Capacitor, they need to reduce the maximum demand, then they improve the power factor. It's a 0.9 to 0.99 means this is a maximum reduce. Then also they will remove the penalty also. You could understand main important, you have, if you have the note that's write it, main important is a reduce the maximum demand, a reduce the penalty. So loads by load shifting everything. This is a power factor improvement and benefits. What are the power factor? Already you know power factor is three phase power is V equal to sorry kilowatt equal to V into I cos pi. This is a induction or capacity everything. But resistance only V into I power. What are the load available? We inductive load like AC motor, induction furnace, transformer, ballast lighting. Inductive load, two kind of power. This is basically sometimes they ask one mark. Active power, which is active power kilowatt. You have to notice this active power is suppose working power is active power, and reactive power create a maintain electromagnetic field. This reactive power what purpose of using to create maintain the electromagnetic field. This is creating a magnetic field creating this one. And sometimes they are asking the unit kilowatt is active power, reactive power is a kVr. Then vector power is what it means, where sum of the kVA means sum of the square root of kVA. I will write the formula. Kilowatt square kVA r square. This is called kVA. It's vector power. Is a kVA apparent power. The active power shift power required to true power is kilowatt. That reactive power required kVr or 90% apart from vertically in pure of inductive. Inductive circuit means it's 90%, 90 degree shifting to the reactive power. Reactive power always 90 shifting to the vector directly. Pure inductive circuit means it's a 90% apart from vertically in is a vector diagram. Shift to the active power. Reactive power is always lagging in active kilowatt. Is always lagging in active power. This vector sum of the two call this is already we have seen that vector power vector sum of the two power is called is apparent power. Very important is a power factor. What is the power factor? The ratio of kilowatt to the kVA called power factor. This is always less than 1 or equal to 1 unity. Loads are inductive in nature with power factor ranging from 0.2 to 0.9. In industrial, they will maximum full they are using the inductive loads. Then power factor this range is 0.2 to 0.9. Then they need to improve that they'll add the capacitor bank, improve the power factor. This is a small calculation. We will see next session. Full calculation everything. Main important is sometimes they are asking 3 mark. Is a power factor. One second. இருங்க ஒரு நிமிஷம். The advantage of power factor is capacitor bank. It's very important. Is what is the main purpose that they are using capacitor bank? Is reduce the maximum demand. Then is automatically this reduce the current also. Main purpose is reactive command that the network is going to reduce the reactive command of the kVr. There's total kVr that is going to reactive command is reducing, and the total current also system. So total current also reduced. Then I square R losses reduced due to the reduction of current, load current. It's the voltage level of the increase. Then kVA loading of the source generator, also the transformer and the line capacity reducing, capacity relief. That means maximum demand capacity also reducing. Main purpose is main important is reactive command reducing and load current also reducing, and load current reduce means then I square R loss also reduce due to the current reduction, and is another one is a voltage level increase at the load end. Then better performance it is doing for capacitor bank using, and maximum demand loading of the source generator. The generator station there increase. Then suppose if you are run the system is low power factor, then they capture the more load, then they will generate more kilowatt kVA, that also reducing. This means this D say kVA loading on the source generator also, and the transformer and line up to the capacitor reducing. Its capacity also reducing. Simple, you have to write the 4 points. Is they are giving the 3 marks. Can you understand, Ganguly?
Oh, yes, sir. Yes, sir.
Main purpose, just you read it. Main purpose is what is the main? It's a maximum reducing, and maximum reduce means it's a current also reducing, load current. Then load current reduce means then I square copper losses. You know the copper losses, reduction of current. Then another one is capacitor boosting the voltage level. Then the system is working best level. Performance also doing. And cost benefit of power button improvement. What is the cost benefit? Main purpose is the maximum reduce. That penalty charge also reducing. This is the reduce the kVA maximum, and charge in the utility bill also reduce, and reduce distribution losses, kilowatt hour within the plant, and the better voltage. This main importance. Better voltage motor terminal. The motor of performance also increase. The high power part means they reduce the penalty charges and they give the incentives. Investment system. Then what is the main important is so they will reduce totally maximum demand. Then no need to invest for the transformer, cable, switch gear. Another load also reduce. There no need to investment for this equipment also extra. It's a main cost benefit. One is what are the benefit, another one is cost benefit. Cost benefit means what is the maximum charge reduce, and distribution losses reduce. A better voltage increase means motor performance increase, then life increase, motor life increase, and high power but they are using the penalty also reduce. They will give the incentives, and no need to invest for the transformer for that extra kVA, because they reduce the kVA. Next is the automatic power factor. What is the automatic power factor? It's automatically control the power factor. Then whenever the power factor is reduced, then automatically switch on the banking.
Capacitor bank.
Automatically switch on the capacitor bank. What are the capacitor bank you need? They automatically switch on, and when power factor is increase some limited, they will put it the limiting is a 0.7 to 0.99. Then 0.9 above going, automatically cut the capacitor bank. This is automatic power factor. It's the main purpose. This one, this bank is some threshold available. Bank of capacity is switched off or switched on. This is the main purpose they are using. Selection and location of capacitor bank. This is a many more important formula. This is a KVR, easily calculation KVR. KVR rating equal to kilowatt tan pi 1 minus tan pi 2. If you are increasing, simple here I will put it the calculation. You want to improve the cos pi is power factor. It's a 0.9. You have planned to improve this 1. This is a formula. This is a formula. Tan pi into pi 1 you need to calculate. Then cos inverse of power factor 1, and pi 2 is a cos inverse of power factor 2. Is you have to calculate this value. Ganguly, you have the calculator, na? Scientific calculator.
Yes, sir.
Okay. This you know how to calculate. This calculation section we will clearly explain how to calculate everything. I will explain. This is a basic formula. You have to write it note. KVR rating equal to kilowatt into tan pi 1 minus tan pi 2.
Yes, sir.
Simple calculation here is they plan to improve the power factor 0.72. Now is a 0.72. This kilowatt is 627. They need to improve the 0.95. 0.95 is how much kilowatt air required. This is a formula. Power is 627. Tan pi 1 minus tan pi 2. They calculate cos pi 1 0.72. Tan pi 1 0.963. Cos pi 2 0.95. Tan pi 2 0.329. This one remember you have to keep it one idea. Whenever it's a power factor 0.72 means it's a tan pi 1 increase inverse proportional to. Okay, this cos power factor increase, increase, this reduce, this is reduce, this increase. This is 0.72, is 0.963, is 0.95, 0.329. Sometimes calculation time we mismatching. So you have to keep it this mind. In this table color model, so you can easily you can use it. This one is a example. Original it's a 0.6. You have to improve this 0.99. Son, you have to code just to mark it here. This is a multiplication factor. You can here now 0.887. This multiplication is for this one. So you have to multiply 627.877. This multiplication you can get it the value. Can you understand the KVA rating? It's very important one mark. Next, location. This is a various type location where they put it, keep it. This is industrial. Here is a motor, directly motor terminal. They are using the fuse, middle of the fuse they are using, and it is a multi machine. They are using the multi motor, 20 motors. This is individual motor. This section is individual motor. This section is 20 motors. This is a source side where we are going to see the what are the benefit. Once you have to install the capacitor, you have to mind it. Everything is a material and installation cost. Material cost is also high. Installation cost also high. So you have, if you are going to plan to capacitor investment, then you have to consider this cost also. Capacitor can be installed at any point in electric system. Will improve the power factor between the point. Here capacitor installed, then it will improve the power factor from source end at the point of application and the power source. Where is power base? Total power factor. Here we are improve. Then total power source also improve the power factor, and load also improve the load voltage. However, the power factor between utilized in equipment and the capacitor will be remain unchanged. Capacitor are usually added at piece of offending equipment, a head up group of small motor, center distribution motor at the main service. They plan to install is a group motor, individual motor also, source also include. Capacitor. Now we are going to see the capacitor on each piece. 1 and 2. 1 and 2 means individual. Here 1 and 2 individual. This is 1 and 2. This is full individual. This increase the load capability. Here the install means the load capability motor will also increase, and they can switch it with always is directly connected with motor terminal. There is no need switch gear, because motor have the another switch gear, breaker and something, but capacitor no need. Better voltage regulations, very important. Better voltage regulations capacitor may use. Capacitor is also simplified. If you are using individual motor, then capacitor size will reduce. Suppose you are using here, the capacitor size also increase, and capacitor coupled with directly equipment, with move equipment, there is no rearrangement. If you are fixing here, there is no rearrangement, only fixed.
Yes, sir.
Can you understand what are, if you are install the capacitor bank motor terminal, what are the benefit? Better voltage performance, better boosting the voltage, better performance of motor also increase, and another one is directly connected with the equipment. There is no switching no need, and capacitor is also reduce. Main important capacitors here investing the capacitor size different. Here install the capacitor, this size different. And capacitor coupled directly with it, there is no movement, there is no rearrangement. This is the advantage. Disadvantage means it is if you are using small capacitor, it's very cost. So we have to consider this at least 10 HP. Can you understand this one? Capacitor is a installation and material cost very high, so we cannot use for that less than 10 HP.
Yes,
Very
sir.
noted. And capacitor selection, very very important, one mark. Is capacitor is always considered the not greater than the no load magnetic resistance kVr of the motor. If you are going to select the motor, then for capacitor bank, then it is not should be the not greater than the no load magnetic resistance of kVr of the motor. Very very important. If it exists, it's damage or damage the motor also. And manufacture also especially the maximum capacity rating also for a particular motor. Next is capacitor with equipment 3. Still now you understand? Any doubts, Ganguly?
No, sir. It is clear.
Okay, I will send the recording one more time, easily you can understand.
சார் ஒரே ஒரு டவுட் சார்.
சொல்லுங்க.
அந்த அந்த வெக்டார் டயக்ராம் சொல்லிட்டு ரூட் ஸ்கொயர் ஆஃப் கேடபிள்யூ ஸ்கொயர் பிளஸ் கேவிஆர் ஸ்கொயர் போட்டீங்களா சார்?
ஆமா.
அந்த ஃபார்முலா எப்படி சார் வரும்? அந்த வெக்டார் டயக்ராமுக்காக அந்த ரூட் வருமா?
ஆமா ஆமா, இந்த இந்த ஏரியா இருக்குல்ல, இதுக்கோசரம் வரும்.
அது ஃபார்முலா காமன் ஃபார்முலாவா சார் அது?
ஆமா, இது காமன். இதோட கிலோவாட் ஸ்கொயர் இஸ் கேவிஆர் ஸ்கொயர்.
அது வந்து ரூட் போடுறீங்களா சார்?
ஆமா, இதுங்க ஆமா, ரூட் போடுறதுக்கு.
அது எப்படி? அதான் கேக்குறேன்.
இப்ப வந்துட்டு பாத்தீங்கன்னா எல்லாரும் இது கேவிஏ இது எடுத்துன்னு வச்சுங்களேன், எல்லாம் போடுறது கேவிஏ ஸ்கொயர் கிலோவாட் ஸ்கொயர் இஸ் கேவிஏ ஆர் ஸ்கொயர். கேவிஆர் ஸ்கொயர் இஸ் கேவிஆர் ஸ்கொயர். இப்போ வந்துட்டு எனக்கு வந்து கேவிஏ மட்டும் வேணும்னா இந்த ஸ்கொயர் அந்த சைடு போய்க்கும், அப்ப ரூட் ஆகி போயிடும்.
சரி சரி சரி.
இதுதான் இந்த ஃபார்முலா ஞாபகம் வச்சுங்க. சப்போஸ் உங்களுக்கு கிலோவாட் வேணும் அப்படின்னா கிலோவாட் ஸ்கொயர் வச்சுக்கிட்டீங்கன்னா கேவிஏ ஸ்கொயர் மைனஸ் கேவிஆர் ஸ்கொயர் மைனஸ் இந்த இடத்துல. இப்போ இது வேணும் அப்படின்னா இது ரூட் போடணும்.
இப்போ மேல ஸ்கொயர் போடுறோம்னா சார், அது வெக்டார்னால ஸ்கொயர் போடுறோமா சார்?
ஆமா, வெக்டார் இது கண்டுபிடிக்கிறதுனால ஸ்கொயர் போடுறோம். இந்த வேல்யூ இந்த ஏரியாவை கண்டுபிடிக்கிறதுக்கு ஸ்கொயர் ரூட் போடணும்.
சரி சரி சார்.
This is very very important, one mark Anguli, you noted this one. Next one is a capacitor with equipment group 3. It's a group 3. Here is available multi-motor. Here is available multi-motor. They are using for the 10 group of motors. What is the load capability also increase? Very important. Always common is load capability increase, and material cost reduce, insurance cost reduce, and this is also main important. Reduce the material cost, reduce the insurance cost. Disadvantage is we cannot switching after the capacitor bank. If you want to only 5 motor, I don't need another 5 motor. It is not possible because it is fixed. So it is very very disadvantage this only. Is switching means maybe require control number of capacitor used. It's not possible. The advantage of a locus is it's a power center of feeder. They can group together. Main important advantage is they use for the group together the capacitor bank voltage, better voltage improvement and forward improvement. Next is capacitor at main service 456. Here 456. You understand here na source side. What is suppose they are using the source side. Same low material installation cost. This is a low material installation cost. Disadvantage is it's not possible to switching. It's very very important. Does not improve the load capability. Very very important. Does not improve the load capabilities because they are using the source end. But load side there is no improvement because here is some transient. Everything is transient. Motor also transient. Then better load improvement there is not available. The disadvantage this one. Another one is from the energy efficiency point of view, capacitor location at receiving substation only help the utility loss reduction. Suppose they are using the capacitor bank here. What's the losses? Here they total losses something say power factor improvement for incoming source side that is possible. But here motor terminal not possible. For a motor terminal need a better voltage regulation, everything need. But we are using here means total power factor improvement, but KV also reduction, but there is no benefit for that motor end.
Yes, sir.
And one more is a power factor. It's a tail end. This is capacitor side they are using here. This is a concept is here. Suppose I am using capacitor bank here. How much power factor loss is reducing? This calculation is there. Very, very important. Locating capacitor at tail end. As tail end to reduce the losses, reduction with the plant. Then they plan to invest the capacitor that reduce the distribution losses. And directly, what is the directly reduce kilowatt hour reduce also reducing losses also reducing. This formula reduction in the distribution loss percentage of kilowatt when tail end power factor is raised from power factor 1 to power factor 2. Suppose they plan to invest capacitor bank here. What is the benefit? The kilowatt loss is also reducing. Then what is the formula? This is very, very important formula. This one 1 minus power factor 1 divided by power factor 2 into whole square into. Sometimes you forget to make it a total whole square, not total whole square. This 1 minus power factor 1 power factor 2 whole square 100. Oh, this is the main important part. Directly you can put it. This is equal to percentage of power factor losses. This is a percentage of kilowatt hour losses. Kilowatt losses. This is a percentage of easily calculation. Percentage of kilowatt losses. Sometimes asymmetric load condition is very difficult to correct the capacitor. They need to plan to according to that. This is because the fifth and seventh hormone is always present. Very important. What is the asymmetric load condition? Always suppose lighting load, induction load, capacitor load, everything multiple load they are using. Then it's always generic fifth and seventh hormone is always present in here. Capacitor for the other load. What are the type they are using? The maybe induction furnace using, induction heater using, arc welding also using. The capacitor are normally supplied with control gear. They are always using some control gear, automatically control the power factor. Application for induction furnace, induction heating. It's very important. Is sometimes they are asking what is the what type of they are using. They are using for with control capacitor with normally supplied with control gear. The power factor of arc furnaces experience wide variation from furnace always change. It's a melting to final product. It's a power factor change is 0.3 to 0.7. According to the starting point is 0.7 to 0.9 change. Then it's according to that they will insert the capacitor bank. Another one more very important is arc welding. It's always power factor correction. The welding method, the capacitor bank always connected to the primary winding. Very important across the primary winding. Next to another one topic only we can discuss. Performance of still now you understand what is the capacitor benefit, where we install the capacitor, what are the benefits, everything. You are investing install the capacitor bank here. Here you can better voltage performance and there is no rearrangement fixed. There is no need to fix the braking equipment. No need breaker and like this. Boosting the capacitor is simplified. Capacitor coupled with the equipment. There is no. This is the basic one. Ganguli, can you hear this one? And disadvantage is we cannot use for the small motor. The cost is very high. Then another one is you have to consider the no load magnetic KVR of the motor. This is very, very important. The capacitor with the equipment group here available here same like the grouped motor and individual source side. Just you can see that this video easily you can understand. And the performance, how the capacitor performance perfectly is a voltage of it. Suppose voltage different rating. Voltage rating is different, but input voltage is different. Or suppose 450 voltage, but actually is 400 voltage. Then what are the effect? This is a formula. reactive, what are the kVA reactive produce will be ratio of V1 square. V1 square means supply voltage. Understand? And
Yes,
V2
sir.
is rated voltage. Simple formula, you write it. This is very, very important. V1 is suppose 400 square divided by rating is 415 voltage. Then you have to calculate it. Reactive power produce. This we can do the calculation easily understand. And material of what are the material using? Dielectric material using. It's paper and polyurethane. Is a material what losses also per kVA how much it will take. This is also you have to consider dielectric material losses also. Connections. It's a shunt capacitor connection. Shunt capacitor we are using for the industrial use. They are using for the end user industrial use. Series capacitor is adapter using for this boosting the voltage boosting. Main important. This you have to consider. Two type of connection is available: shunt capacitor, series capacitor. Shunt capacitor we are using for the industrial, for motor terminal and everything for better performance, power factor improvement. And the series capacitor using for the boosting the distribution system. Next is operation performance. This operation performance, suppose you install the capacitor, you want to measure the charging current, also need to measure, because suppose charging current is higher, then capacitor bank will be damaged. So you need to fix the fuse also. Some rating fuse also you have to consider and fix this. So capacitor fused element can be replaced as per the requirement. What is the sometime we need to measure the portable analyzer used for the measuring the kVR delivery as a charging current. You have to use the portable analysis measuring the charging current per kVR. This is a calculus. This is a actual condition. They are putting the nameplate details, everything, but actual condition you are inside the motor, there's some charging current may be changed. Sorry. And on one more factor you have to consider: nameplate detail. Sometimes you are purchasing another capacitor also as per the motor. You have to consider the misleading, nameplate also misleading. If you could check, you have to consider the charging is very, very important. Capacitor box should be inserted properly. Terminal also should be inserted. And the capacitor was single phase motor starting, and those used for lighting circuit voltage boost. They are not power factor capacitor, and this cannot withstand power system condition. Suppose sometimes there are capacitor selection time you have to consider whether using for that lighting purpose or motor purpose. Suppose motor single phase motor starting purpose they are using capacitor. You know, starting purpose one motor is available, charging current. It's boosting the voltage, then single phase motor running. That capacitor cannot be used for the lighting circuit. It will not boost for the it will not boost the power factor. So we have to consider what purpose of capacitor we are purchasing. Very, very important. Can you understand? Na? Capacitor for single phase
Yes,
motor starting. This is motor starting. We are purchasing for that motor starting, but we cannot use for the lighting circuit. Ganguly, still how is classes, Ganguly? Can you understand?
Yes, yes, sir.
Okay, can you explain still now what are the how you understand? Because I need to improve, then so I am asking.
Yes, yes, sir. Yes, sir. I will, sir. First, I will go through the what we have taught today.
Okay.
Then it will better for me to explain.
Oh, easily I need to one time that you have to do na. You have
Yes,
to.
first 1 or 2 times I will go through the um, recordings which you have taught.
Okay.
So actually I understand what different what the advantages of capacitors and where it is to be placed, in the motor side or at uh, end user side,
Okay.
and what are the advantages of placing the capacitors at different places,
Yes.
and what are the disadvantages also?
Okay.
What are the cost benefit of using the capacitor bank, and what are the advantages of using the capacitor bank?
Okay, Ganguly. Any improvement from my side? I need to improve something, then I will improve. Better you have to
No,
understand,
no,
but you need to understand. That is my main motto. But I am teaching,
no.
there is no issues. But according to, I want to improve because what do you think? Everyone thinking. What do you think?
Yes, sir, from your side, you are okay, sir.
Now is a only theory. We will connect it with calculation also. Calculation, you always keep it one notebook and calculator, pen and paper. That time you have to do with me. Can you understand?
Yes, yes,
Because I am giving alone,
I have.
you are not doing. So always we are doing with us both.
Yes, yes, sir.
Very useful this one. You get confident. No?
Yes, yes, sir.
We plan to 1 week 1 chapter. Hereafter 1 week 1 chapter we will easily complete it.
Yes, sir.